Hey, calculus. Before we dive into the chain rule, let's look at these 4 examples. So go ahead and pause and work them out. And then we'll just talk about them real briefly, but it's super important that you understand where that squared falls and what the squared means on the sine and this cosine. That squared means sine of x, or sine of pi over 3, all squared. That means you do sine of pi over 3 first and then square it. So it's real important to know what that means. Okay, so before we talk about chain rule, let's look at this first example and how we would solve this. Right now we know product rule, quotient rule, and power rule. So we could write these side by side and do product rule, or the easiest way would be to just multiply this out. So we get 2x minus 3 times 2x minus 3, which is going to be 4x squared minus 12x plus 9. And then we can take the power rule, so y prime is 8x minus 12. And that would be pretty easy to do. The problem, though, is when we get to a 30th power or a 1/2 power and we can't multiply it out, or I guess technically we could for the 30th power, but who would want to? And so instead, we can do what's called the chain rule. So to do the chain rule, we'll do this first problem again, this time with the chain rule. You have a function inside of another function. So here we have 2x minus 3 inside of a squared. And so we do the squared first. So we do the power rule on the squared, ignoring what's inside. We just leave that inside as it is, and then we multiply by the derivative of the inside. And then if we simplify that, we get 4x minus 6 times 2, and there's your 8x minus 12. So same thing, so that problem either way, both pretty simple. So how does that look for the 30th power? So let's call this one dy dx, which is the same thing as y prime. We're going to do the power first, so that's 30 out front. Drop the power down by 1, keeping the inside as it is. We leave the 2x minus 3 inside, and then we do times the derivative of the inside, which is 2. And then if we take a minute to rewrite that, we get dy dx is 60, 2x minus 3 to the 29th power. And let's do the same thing with a 1/2 power, which you could also see as a square root. So we put the 1/2 out front and drop the power down by 1, so negative 1/2, so that's the power rule. We keep the inside, and then we do the derivative of the inside. And then we can rewrite that one. Dy dx, 1/2 times 2 is 1, so this ends up being 2x minus 3 to the negative 1/2 power, which you might see as that, or you might see 1 over square root, 2x minus 3. Okay, so this is that chain rule. This is the notation for that. So if you are taking a function inside of a function, you have g of x inside of f of x, the chain rule says take the derivative of the outer function, take f prime, keep g inside. So the derivative of the outside, keep the inside, and then multiply by the derivative of the inside, so g prime. Make sure you're taking one derivative at a time. It gets a little complicated when you've got multiple functions inside of multiple functions. Okay, so let's do some examples. Find the derivative here. First, we need to rewrite this as x squared plus 1 to the 1/2 power, because we need to be able to do power rule. And then y prime is going to be, we're going to do the 1/2 to the negative 1/2. That's the power rule. Keep that inside as x squared plus 1. Then you can do times the derivative of the inside, which is 2x. And then a quick rewrite of that. Y prime, 1/2 times 2 is just 1, so we just have x and then x squared plus 1 to the negative 1/2, which you also might see as x over square root of x squared plus 1. All right, here's another example. You could do quotient rule here, but that would be really messy, and we never want to do quotient rule with a constant anyway, because this is easily rewritten as 3x minus 5 to the negative 1. That's how we bring that up top. And then we can do chain rule. So y prime, we're going to do that power first, negative 1 out front to the negative 2 power, leaving 3x minus 5 inside, times the derivative of the inside, which is 3. So a quick rewrite of that gives us negative 3 on top, 3x minus 5 quantity squared on the bottom. Here we have another example. We do not need to rewrite this, so we can just go ahead and start. Y prime, we're going to put the 3 out front, drop the power down by 2. So we're just doing power rule first. Leave the inside exactly as it is, and then times the derivative of the inside. So 3 minus 4x. Not much to rewrite there. You'll probably see maybe the order written differently. So y prime might be 3 times 3 minus 4x, 3x minus 2x squared. Might see that 3 distributed in. Basically, you just have to be able to match that with a multiple choice. Otherwise, any of those forms are fine. All right, when we have a square root, cube root, we need to rewrite. So this is x squared minus 1 squared to the 1/3. And we can make our lives a lot easier by simplifying that more. We have a power to a power, which we can multiply. So x squared minus 1 to the 2/3. Now that is a function inside of a function, so we take the derivative of the outside, 2/3, subtract 1 from the top, so negative 1/3, so that's derivative of the outside, keeping the inside, x squared minus 1 stays the same, times the derivative of the inside, which is times 2x. And then again, we can go ahead and rewrite that. Y prime is going to be 4x on top, 3 and cube root of x squared minus 1 on the bottom. I should move that 3 in a little bit closer. And there's our final answer for that. Okay, let's keep going with chain rule. Remember all of our trig derivatives, because we're going to add those in. And this time, there's going to be something inside of the sign more than just an x. So here we have an inside of 3x. So it's the sine of 3x. So the outer function is sine. The inner function is 3x. So dy dx, or y prime, is going to be the derivative of the outside, which is sine of, sorry, that's not right, cosine. Derivative of sine is cosine. So cosine, derivative of sine is cosine. Keeping the inside as 3x times the derivative of the inside, which is times 3. Then the rewrite of that is, we just put that 3 out front. So 3 cosine 3x. All right, same thing on number 2. 4x is our inside function, and so our outside function is cosine. And so we're going to take the derivative of cosine. That 2 stays out front. Derivative of cosine is negative sine, so we're going to put negative sine of keeping the inside of 4x times the derivative of the inside. The derivative of 4x is 4. So a rewrite of that, dy dx is negative 8 sine of 4x. Okay, if you feel like you're getting it, go ahead and pause and try to work these on your own. Otherwise, I'm going to keep working through them. So for number 3, the inside is 2x. The outside is secant. So dy dx, or y prime, is going to be 1/3. That constant stays out front. The derivative of secant is secant tangent. So secant tangent, keeping the inside stays 2x in both of them, times the derivative of the inside, which is 2. So dy dx is 2/3 secant 2x tangent 2x. All right, on number 4, the inside is 3x squared plus 1. So we need the derivative of cotangent. Remember, the derivative of all the cos are negative, so this is going to be negative. And the derivative of cotangent is negative cosecant squared. So we are negative cosecant squared. That's the derivative of cotangent. Keep the inside as 3x squared plus 1 times the derivative of the inside, which is 6x. A rewrite of that is negative 6x cosecant squared 3x squared plus 1. And the last one like this, inside is x over 3. So we want to call this one f prime because it was called f to begin with. So the derivative of cosecant is cosecant cotangent with a negative. There's already a negative, so that becomes positive cosecant cotangent, keeping the inside as x over 3, times the derivative of the inside. You might have to think of the inside as 1/3 x, so that the derivative of the inside is 1/3. A rewrite of that gives us f prime of x is 2/3 cosecant x over 3 cotangent x over 3. All right, now if you look at this next set of examples, these are just more complicated. There are more functions inside of other functions. And so we need to figure out that order. And so sometimes if you take what you would do to x, you can figure out that order. So if I were to plug in an x, I would first do 2 times x, and then I would take the sign of that, and then I would do the 4th power. And so you do have to think of this as sine of 2x to the 4th. The 2x is inside of the sine, which is inside of the 4th power. So if we take the derivative here, we're doing 4th power first. Don't touch anything else. You can only take one derivative at a time. So y prime is we're doing the 4th power first. So 4 to the 3rd. That's the only derivative you're taking at this moment. You keep the inside the same. So the inside remains as sine of 2x. And look back at your original problem. And sometimes it's easier just to scratch off that 4. If that 4 is gone, now the rest of your derivative is the sine of 2x. So now we're going to take the derivative of sine, which is cosine, leaving the inside of 2x, times the derivative of the inside of that, which is 2. A rewrite of this is 8 sine squared, not squared, sine cubed of 2x. That is the way to write it. Sine of 2x cubed means sine cubed of 2x. It's just the notation. That's just how we write it. And then we also need a cosine of 2x. All right, let's try another one of those. So here we have pi over 4x. That's our most inside. And then we have cosine. And then we have the 4th power. So if you want to, or 2nd power. So if you want to rewrite that, it's cosine of pi over 4x all squared. So that outermost function is the squared. So if we were to figure out the order here, what would we do to x? We would first do pi over 4 times x, then we would take the cosine, and then we would square it. And so the reverse of that is the chain chain rule order. So power rule first. Y prime is 2 out front. Drop the power down to 1, which we don't need to write. Leaving the inside, cosine of pi over 4x. Go to your original and take off that squared. Now you are just doing the derivative of cosine of pi over 4x. So the derivative of cosine is negative sine. Make sure you put parentheses there, because if you write negative sine, it's going to look like minus sine. Keeping the inside, pi over 4x, times the derivative of the inside of that, which is just pi over 4. A rewrite of that is a negative out front, a pi over 4 and a 2, which makes pi over 2, and then cosine pi over 4x and sine of pi over 4x. All right, another one, and again, if you want to rewrite it with that fourth power out, we've got 3, and then we've got tangent of x over 2 to the fourth power. So that fourth power is the outermost function. That is the outside. That is the first derivative that we do. So y prime, we're going to do fourth power. So that 4 is going to go in front, multiply by 3, that's 12. Drop the power down to 3. Keep that inside. Tangent of x over 2. What's inside the fourth power? That's the tangent. So now we take the tangent derivative, and the tangent derivative is secant squared. So now we have secant squared, keeping the inside of x over 2, times the derivative of the inside, and you can think of x over 2 as 1/2 x, so the derivative of that is 1/2. Now in the rewriting, make sure you know that tangent x over 2 stays together, secant squared x over 2 stays together. We're going to move this cube to be on the tangent where it should be, and so the only thing we're combining here is the 12 and the 1/2. So y prime is going to be 12 times 1/2 is 6, so 6 tangent cubed x over 2 secant squared x over 2. Okay, and let's do one more. This one we're going to have to rewrite because we can't do the square root, so this is going to be 4 cosine of 3x to the 1/2 power. So the outermost function is 1/2. There is a cosine inside of that, and there is a 3x inside of that. Those 3 different functions are the 3 things you're taking the derivative of. The 1/2 power, the cosine, then the 3x. So 1/2 power first. So f prime of x is 1/2, which we're going to multiply by that 4. So that's actually 2 to the negative 1/2 power. Keeping the inside, cosine of 3x. The next derivative is cosine. So the derivative of cosine is negative sine. Again, if you're going to have a negative, make sure you put parentheses there, or else it looks like minus sine, and that is not what we want. So times negative sine of, keeping the inside of 3x, times the derivative of the inside, which is 3. So again, cosine is our, that's going to go back to a square root on the bottom, just like that. Sine of 3x stays together, so we have a 2, we have a negative, and we have a 3. That's what's going to go out front. So f prime of x is negative 6. We have sine of 3x on top, and on the bottom, we have that cosine that we're going to move to the bottom and square root it. So cosine of 3x, square root. And then just one note before you go off on your own to do work is what that squared looks like. So it's super important that you understand the difference between these two. This first one is what we've been doing, sine of x squared, versus the second one is sine of x squared. So in this first one, the squared is the outer function, sine of x is the inner. And so if we take the derivative of this, f prime of x, we do power first. So 2 out front, drop the power down by 1. There's your power. Sine of x stays inside. The derivative of that is cosine of x. And the derivative of the inside of that is just 1. And so we don't need to write anything there. And so our rewrite here is not really a rewrite. It's just 2 sine of x cosine of x. Whereas this other function, the x squared, is inside of the sine, and so the order changes. So the outer function is sine, x squared is inside of that. So the derivative of sine is cosine of keeping the inside times the derivative of the inside, which is 2x. You get a very different result, which is 2x cosine of x squared. So make sure you understand where that squared goes. All right, that's chain rule.